to make sure I've got this right.
Okay, so I finished transferring all of those over. Here's my lovely assistant. You look nothing like that chick off Wheel of Fortune. You know that Adriana? I mean, you do look like her, that's what I meant. So I've transferred 20 microlitres from each into the wells below, okay? You probably can't see that from there, but you can see underneath where I've transferred it, it's got a little bit red. So at the moment, we can't tell where our protein is. We can tell where our red protein is, but we can't tell where our other protein is. So we're going to use Bradford reagent. Again, you're going to have to read the information that Jenny has given to you about how Bradford works. We've spoken about this. I think we did this on the last video we had Bradford. You remember I said it was in a coloured container because it's light sensitive. Actually, it was NAD we used. Okay, so Bradford reacts with protein. Bradford... This would be a really good quiz question. Bradford, when it doesn't have protein, will be brown. When it finds protein and it reacts with it, it will turn blue, all right?
Check out my information sheet.
Yes, check out the information sheet. So we can actually do this two ways. We're going to see the colour change. So we can have a look at it and I can, by eye, I can say this is where my protein is because I can see it turn blue. And that's exactly what's going to happen when we put it into a plate reader. It does what's called a colorimetric assay. So it will analyse the colour that's in there. And wherever it is bluest, it's going to give us a higher absorbance reading, okay? So when we get to that sheet, I'll show you, and it'll correspond, so our highest absorbance reading will correspond to where our bluest parts of our Bradford are, which corresponds to our highest amount of protein. Okay, so Kat now is going to dispense 200 microlitres of Bradford into all of those second wells. As we go into that, you can actually watch the colours appear.
Magic.
Can I tilt this? Can you see the colours from there? Beautiful. She's got an automatic dispenser, so instead of having to do it one at a time, she just pushes the button and she cheats.
Oh, it's so nifty. It's only $1.5 grand. Hey Barb, you know how I was a catalyst last time?
Yes.
Can I be a cat iron this time?
Cat eye on. Okay. Go, dispense.
Where am I going?
Oh, so row B.
Are you tilting it?
No, that's okay. Not necessarily you want me to. Okay, row B.
I'm blind as a bat.
Blind as a cat.
Stop, I've got a shaky hand. Okay, are you ready?
Go. Brown. Blue.
Ooh.
Blue.
Oh.
Blue.
Look at that.
Blue. Blue. Brown. Brown. Brown.
Oh.
Awesome. I hope you guys can see that.
Oh, that's beautiful.
It reacts instantly. It's pretty
gosh,
cool.
it's
So
blue.
now we can see where our protein is. So now we're going to go into the row below it. And as you would expect, you're going to expect it to turn blue where it corresponds with the red, right? Okay, so go. The row.
Let's go. Oh, hang on, I'm blind as a bat.
That one. Yeah, that one. Brown, 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 brown.
Whoa!
Blue, brown, brown, brown. Okay, so that's a perfect example of, you can see it corresponds directly with where we know that protein is. So this is the way that we can see our protein, even when we can't see our protein. Okay, so that's our pH 8 and pH 12 done. Now we're going to move on to the row of pH 8. So you would expect, yeah, the pillagers.
The pillagers.
We're going to move on to the pH 8. You're going to expect it to be the same as
Chicken
row A.
destroyers.
Bark, bark.
Super chicken.
Oh gosh, I am so blind.
Yeah, just there. That's good.
Okay, are you ready?
Go.
Okay.
Oh!
Hey.
Look at that.
So as we
that's a
expected,
very tight band.
it's exactly the same as row A. So now we're going to continue onto our very last one, and this is where we took the protein off the column using a high salt concentration. Again, where would we be expecting it to go blue?
There.
Beautiful, where it's red. Okay.
All right.
Off you go.
Oh, I can see this one. I'm such a cat iron. Oh, oops. Way!
Good job. Look at that.
Well done.
That's amazing.
Okay, so there we are.
Wonderful experiment.
Perfect. So
Good
now we
job,
have our
Kat.
full plate. So what we now have, importantly in science, what we need to do is we need to retain our original samples. Once we've put Bradford in with our protein, that protein is no longer functional or usable in any further experiments. So row A is still now our pure protein. So we can experiment and take that further, we can analyse it further, but all the rows with the Bradford in it, B, D, etc., that's what the plate reader is going to read, but we can no longer use the protein that's in those coloured solutions, okay? All right, so now we're going to flick across. I'll see you shortly at the plate reader. Okay guys, here we are down at the microplate reader. You don't need to see this bit, but I'll do it for you. So this is where we're going to read our plate. All we do is we just open it up, put our plate in, press something. Cat?
Big OK button.
Are you ready?
Oh, we press the start button. I'm all over this. Okay, so it's now measuring the absorbance of that plate. And we're going to get a printout and it will show us the absorbance values. If you remember, the last time we did this experiment, we actually put this into a spectrophotometer and we did them one by one. We could do the same thing, only we'd be here forever. A plate reader does this a lot faster for you. All right, let me just get a quick printout. Quick printout. Voila! All right, so here's the printout that we got from analysing our plate. I want you to take note that it has A to H and it goes 1 to 12. So this is an exact printout of the absorbance values of this plate. Okay, so we have A to H going down and we have rows 1 to 12 going across the side. So now take note that these are our pure samples. So A, C, E and G had nothing in them. The ones that had the Bradford reagent, so the colour, is in B, D, F and H. So that's where we're going to be looking for the highest absorbance, because that's where it's detecting the colour and it's giving an absorbance value for it. So the highest absorbance peak is where the maximum amount of protein is. So if we were to have a look at the plate, even before we had a look at the absorbance readings, we would assume that about here was going to be our highest, and we'd assume that about here would be our highest. So what we do is we go across and look in row B and we find where it is. So 1.69, 1.7. So here we have 1.67. That's our highest absorbance. So again, if we have a look here, A4, that corresponds exactly to what we were talking about. So that's the fraction where we're going to have the most of our protein in. So then we're going to find, so that was our pH of 8. And here's our pH of 12. And our highest absorbance in row D is 1.273. So here is our highest here. All right, so that was the end of that one. So then we're going to move on to the pH of 8 again. We'd expect it to be in around about the same place. Actually, it comes out a little bit sooner, 1.682. And here is our high salt. Our high salt came off at 0.167. Okay, so now what we're going to do is we're going to go on further and we're going to analyse the protein that we took off to make sure our protein really was pure, and we're going to have a look at the charges. So rather than taking our samples out of where the highest absorbance was, we're going to take that sample from our pure sample in the one above, okay? So where that highest reading is in our Bradford, we're going to take our sample out of here. Where this one was, we're going to take our sample from here, our sample from here, and our sample from here. All right, and I'll see you at the next step. All right, so we're going to move on to section 3. This is electrophoresis on cellulose acetate plates. And we're going to take advantage of these wells here and a stamp to put them onto the plate. The reason we're going to do this is we're going to analyse this cellulose acetate plate so we can observe the properties of the proteins at a pH of 8. We want to see their characteristics. So we're going to take the samples of the peak fractions that we isolated earlier to put them into these wells. So if you want to turn to the methods, you can follow along. We've already cleaned the plate and we've cleaned everything on there. So we're just up to the part where we're going to put 20 microlitres into each of these wells. So it says well 1 protein mixture. So Jen has now taken 20 microlitres of that protein mix. So that's got our cytochrome C and our BSA in it. And we're going to place that into that first well. The next well we're going to leave empty. It just makes it easier when we do our analysis so that we can see where our proteins are. So well 2 is blank. Well 3 is going to be the peak fraction from row A. So if you think back to when we did this printout, we're going to have a look here, Jen, and row B gave us our highest print. So we're going to take our pure protein from A4.
1, 2, 3, 4.
Beautiful. So that should be our first protein, whatever came out in that first elution. So it should have been negatively charged, repelled straight off the column, and that's our sample. Perfect. So well 4 is going to be the peak fraction from row C, and our peak fraction from row C was 7. So we're going to take it.
5, 6, 7. Leave the gap.
No, sorry, so that goes into well 4. Beautiful. And so because of the colour, we can already guess which protein that is, right? So well 5 is now going to have the peak fraction from row E, which was
4.
3.
1, 2, 3.
Beautiful. That's in well 5.
1, 2, 3, 4, 5.
And well 6 will be the peak fraction from row G. So row G, so we're looking at 6. Well 6. Which is obviously the red one, because we know that's where the protein is. And again, we can guess which protein that is. And that's well 6. Beautiful. So the last 2 wells, we're going to put in our standards. So by standard, I mean this is proteins that we've previously separated. So in well 7 is only going to be cytochrome C, which is red, which is a big giveaway. And have a think about why we're using these standards. This is one of the most important principles in science. Thank you. So in well 8 is going to be our standard BSA. Every experiment should have a control, whether it's a positive or a negative control. You have to have something to judge by, okay? So now here is 20 microlitres of our standard BSA going into our last well. Beautiful. So now we have, if you have a look at your protocols and methods in front of you, you'll see that wells 1 to 8 has now been filled. So what we're going to do is we're going to take out our cellulose acetate plate from the soaking container. So we moistened that, and that's been, I can't believe I said that word. We soaked that plate previously, and we're going to take it out. Nobody likes a moist plate. All right, so we're going to take out, we're going to take out our cellulose acetate plate, and we're going to just quickly dry it. We're going to pat it dry. One of these sides is going to be shiny, and you can see because the bubbles form, and the other one is going to be dull. Please remember which side's which, because that also makes a really good exam question when I'm asking you which side and why. So we don't want to print on the shiny side, obviously. The cellulose acetate is the dull side. So we're now going to place that into our holder,
Beautiful.
halfway across with the dull side up. Jen's now going to take our applicator, our little stampy thing here, and if you want to press the top of it, you can see how it works. So if you press this top part gently,
Yeah.
beautiful. It works just on a stamp principle. So if we turn it sideways, you can see here, as I press it, it just pushes out. All we're going to do is Jen's going to put it, rock it in here. She's going to push it down gently. So it takes a little bit of each of those wells over, move it into here, and then she's going to push it down and just hold it for a second. Okay, then we've transferred a little bit of each.
So I just pop it in here.
Yep.
Okay. And do I push this down?
Push it
at all?
down. Yeah, give it a bit of a rock so that you know that it's picking up. Beautiful.
Okay.
Let
then
it go.
I let it up.
Yep.
And then I do the same thing
Transfer it over.
over to here.
Yep.
And then I just push it down, do I?
Yep.
And
Okay.
nothing seems to be coming out.
Yep. No, that's fine. See it sits in. Yep, that's good.
Oh,
Okay,
you
so
can actually see it.
as Jen said, it didn't look like anything was happening, and that's because we're transferring such a small amount, okay? And again, in science, this happens a lot. We'll transfer minute amounts that we can't see, but that's enough for our analysis. So even though you can't really see any colours, we can see a
There's
very...
real faint red.
Yeah, we can see very faint red. So the thing I want you to appreciate is that we loaded these proteins right in the centre here, and we're going to call that our origin, our line of origin. So I'm going to get you to draw this when we've finished, and I want you to put a dotted line across the middle because that's where all our proteins are going to start. So we now have our protein mix, a blank. We now have our peak fractions from those 4 rows, so it should be a certain protein, another protein, a protein, another protein. Then we have our standards. So now we're going to use a buffer at a pH of 8. We're going to run electricity through this, and we're going to run it so that it goes positive one end, negative the other end. So you could assume what's going to happen. These proteins are going to get drawn to their opposite charge. So any protein that is negatively charged is going to get drawn to
Positive.
beautiful, positive end. Any positively charged protein is going to be drawn to the negative end. So where we're going to start here in the middle, we're going to see a split, and we're going to see those move either direction. And we'll come back to that and we'll pick it up after we've got it onto a charge. Okay, here we are guys at the cellulose acetate plate, and we're at the electrophoresis machine, and what we're going to do, we're going to get Jen to load this on. So here we spoke about, this is going to process our charge. So we're connected to a power pack, we can then monitor this. So if you can see across the top, it actually has a positive and a negative side. So this is the way that we're going to run. We're going to put our protein so it's sitting in the middle. We're going to start the charge, and this is the direction they're going to run, obviously. We have paper wicks down here, and in here is our buffer. So our buffer sits in here. These little bits of paper sit down, and it just keeps that wet, because without liquid, the charge has nothing to flow through, okay? Another important part with electrophoresis is it always needs some sort of buffer in which for the electrons to move around. So what I'm going to do is I'm going to get Jen to gently slide that off without touching the cellulose acetate part. Okay, so our proteins are on that. Yep, you picked it up. And we're going to turn it face down. So dull side down, beautiful. And we're going to rest it across those 2 wicks. So,
This way?
Yep, that way. So here we have the way she's going to put it down, beautiful. Now has our line of origin is down the middle here, okay? So that's where our wells are stamped.
Yep.
And now she's going to get 2 glass slides, and we're going to put the glass slides, just put one across here and one across here, just lay them on top. And that's just going to make sure that our cellulose acetate plate has a weight attached to it in order to make sure it stays in contact with that charge, okay? Otherwise, being cellulose acetate, it might move around. We'll just stick it down here a bit. Okay, so now we have our proteins directly down the middle. Beautiful. Jen's going to put the lid on that. Push it down nice and tight on both sides. Make sure it fits. Beautiful. Okay, so then we're ready to go. So we're going to set this to 180 volts, and we're going to let it run for 15 minutes. So Jen, if you want to press the run button on there.
run.
Beautiful. So that's now coming on. So now what's going to happen is we have our protein sitting down the middle.
Oh, look, the voltage is going up. We're at 2 milliamps.
Beautiful.
We've got charge and we've got voltage.
Okay, so now what's going to happen is that charge is going to run through. So anything that's positive is going to be pulled towards the negative end. Anything that's negative is going to be pulled towards the positive end. So if these were really stained darkly, we could actually watch them migrate. Yeah, it's pretty cool. But what's going to happen, we're not going to stand here. I'm sure you don't want me to dance for you. And I don't know, cameraman, you can dance again. So, no, he's still in this. Okay, so we're going to let this run for 15 minutes and we'll come back and we'll show you where we're at. All right, so 15 minutes has passed and we are going to, I've pressed, take the lid off this and we're going to transfer this over. So if I take these glass slides off, and for the moment if I place this, we can't really see it very well, if I place this down into the container that we started with, it's a little bit hard to see, but you can see that the red has actually migrated. So this part in the middle is where we stamp those proteins to start with, and you can just see a little hint of red. Well, I can from here. I can see the red has migrated down this side. I can't see anything on the other side, obviously, because that protein wasn't coloured. Okay, so we couldn't stop the experiment from here because we can't actually see what's happening. So what we're going to do now is we're going to move across into the last part of this laboratory, and that's to stain this acetate plate up so that we can have a look and see where our proteins ended up. Be back in a minute. Okay guys, we're nearly at the end of this prac session. So I'm going to take the cellulose acetate plate. We may have had a little accident with it previously, but we're going to take the cellulose acetate plate that we got from the electrophoresis machine. We're going to slip it into this plate holder, and now we're going to stain it. So this is a section where we're going to be able to stain up to see where our proteins went, and we can see which went towards which end. So the very first one we're going to put it into is a container containing Ponceau Red. And as it sounds, could you please get me the top-up bottle cap of Ponceau Red? As it sounds, it's a stain. So it has acetic acid in it. Beautiful. Might just put a little bit more. Is that all right? I promise I won't get red stain on your stuff. All right, so we'll just make sure that there's enough there to cover our slide. Just add half a bottle. Okay. So again, we're not going to go through this whole thing with you because we will be here forever. But I'm going to take you through the process and show you what it comes up like at the end. So it goes into this Ponceau stain for 6 minutes. It'll sit in there, it will turn a bright red colour, and somebody sits here with a timer and we count it down, and at the end of 6 minutes it will go beep, beep, and we're going to move it along. Okay, so if you were in this lab, you would have everything set out and everything tells you what to do. It tells you 6 minutes in the Ponceau stain. The next thing it's going to go into is methanol for 2 minutes. I've got 3 lots of methanol set up here because as it goes into the first one, it loses a lot of its colour into the methanol, so we wanted to put in fresh methanol to give it a chance to destain further or to take further. We're going to put it into another methanol again to take it even further, so that way it doesn't keep getting too saturated in solution. All right, so our 6 minutes for here is up. Beep! Again, we're going to take it out and try not to drip it. And we're going to move it into our methanol solution at the back, and it's going to sit in there for 2 minutes, okay? Beep. Beep, beep. Okay, so now we're moving along. We're going to move it into our next methanol one. Oh, shoot. Sorry about the drips. Okay. Now it's going to sit in here for 2 minutes. Beep. All right. Now it's going to move into the last methanol for 2 minutes. Beep, 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 beep. Well, how time flies when you're having fun. So now we've had 6 minutes in total in methanol. Now we're going to move it into acetic acid. So the acetic acid, what that's going to do is that's going to destate our solution. So the red will take to where our proteins are, and now we want to take the red off the background so we can just see our stained proteins. So we're moving it across now into our 5% acetic acid. Oh, a little bit of a drip. And it's going to sit in here for 2 minutes.
Beep, 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 beep.
That's very fast. What does it say? So confused to say. Okay, so now it's been sitting in here. I don't know, it's on that. You should never do that now. It's been sitting in here for 2 minutes. Now we're going to move it to the clear aid. So the clear aid is exactly what it sounds like. It's just one step further in the destaining process, all right? So we will take it from here into our destaining process, and it's going to stay in here for 7 minutes. We're going to keep you here for 7 minutes. 7 whole long minutes. That's probably 20 seconds now.
Beep, 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 beep.
Okay, we lied. We're not going to keep you for 7 minutes. All right. So now that it's finished, hang on a minute. Here it is. Here's one that we've completed earlier. It's stained up beautifully, and you can see that it's destained nicely in the background. So importantly, what I want you to see now is that these proteins have run different directions. So if this was our line of origin, starting down the middle, and we didn't know which way around this plate was, so we've put it in and it's changed direction, so I don't know which way round, I stamped it. Kat, any idea how would I be able to tell which end was which?
Go back to the original way you dipped it from.
I could do that. I snorkeled. I could go back and try to work out which way I previously put it in when I first dipped it, but chances are that's not very good.
No,
I'm not going to remember. So instead what I'm going to do is I'm going to take advantage of two things. One, I'm going to take advantage of
Standards.
the standards. Beautiful. So that's one of the reasons that we have standards. So we know that we put in a protein mix to start with. That was in the first lane. Then we had an empty second lane. So the other thing that I could do is I could have a look and see where that empty lane was, and I would know which end that was. Okay? So in this one, I can actually see that my empty lane, my lane 2, is down the middle here. It might not be so easy for you to see, but I know it's there from here. So that would make my standards at the other end. I'm correct here? My piece of paper. So if our standards were at the other end, they'd be in lane 7 and 8. Kat, can you tell me what was in lane 7?
Lane 7 was cytochrome C.
Was it? Oh,
Yeah.
good. I was guessing. Beautiful. Cytochrome C. Well, if that was in lane 7, then the BSA is in lane 8. So cytochrome C at a pH of 8, was it positively or negatively charged?
The cytochrome, positive.
Was positively charged, correct.
Whoa!
So if the cytochrome C is in lane 7 and it's positively charged, then this all has to be cytochrome C, does it not?
Correct.
And if the BSA was in lane 8 and it's negatively charged, then it's been drawn towards the positive end, and everywhere that we see a dot must be the BSA. So now if we go back to our books and we have a look where we loaded this, okay guys, so here we have our plate that we've stained previously, okay, and I'm going to take you through why it should look the way it does. So if we're not sure which way round our plate went, so we've dunked it in that many times, upside down, around, and we don't know which end is which. So this is the reason that we use our standards. If we're not really sure which way round, we can orient ourselves in two different ways. The very first well that we used, well 1, had a protein mixture. So what was going to happen is if I draw a line through the middle here, this is where we first put our proteins down. If you remember, this is where we stamped them. And then we stuck it into the electrophoresis, and the charge went from one side to the other, positive to negative. So what we'd be looking for is the protein mix. So if our protein mix started here and it's split, those two proteins will run different directions. One will run this direction, the other one will run this direction in the same lane. That's very cool, and that's a way that we can get those proteins to separate via charge. But that still doesn't tell us which end is which. So we know that this was our protein mix, so we know that this was lane 1, okay? But we still don't know which one of these is cytochrome C and which one of these is BSA, so we don't know which end is positive and which end is negative. Lane 2 was empty, so there's nothing in there that's going to be able to help us. Lane 3 was our peak fraction from row A. Lane 4 was our peak fraction from row C. Lane 5 was our peak fraction from row E. Lane 6 was our peak fraction from row G. And now importantly, we used the standards. And remember, I asked you to try and think of a reason that we would use standards. Well, this is one of them. Importantly now, we know that in well 7, we've got 2 here, that's 7 and 8, row 7 we loaded cytochrome C. So I know that that band there is cytochrome C. The same way as I know in well 8 is our standard BSA, okay? So because we were at a pH of 8, our cytochrome C at a pH of 8 is positively charged. So cytochrome is positively charged, so it will be drawn towards the negative end. So this end has to be negative. BSA was negatively charged at a pH of 8, so it's going to be drawn towards the positive end. So we know that this end was our positive end. So now we can work out our fractions. So now we know our protein mix. One half of it went one way, one went the other. So we can now see that our cytochrome C split this direction and our BSA ran the other direction. Our peak fraction from row A in well 3 was our BSA. So if we have a look back at our experiment, and I want you to go through the protocols and have a look at where we first eluted that protein off the column. It was when we originally did the experiment at a pH of 8. We put the protein mixture on. Whatever was negatively charged was going to be repelled off the column first, and it was going to be eluted out straight into row A. We now know that BSA was that first protein because with a PI of 4.6, that's lower than a pH of 8, therefore it carries a negative charge. Okay, so all this we can now double check. So now if we go to peak fraction from row C, we know that that was cytochrome C because this is where we changed the pH to a pH of 12, if you remember. And so that's why it changed its charge and it ran the other way. Now I don't want you to get confused. So when we changed that pH to 12 and cytochrome C changed its charge value, then why did it still run towards the negative end on our plate? The reason being is that the buffer we used when we ran our plates was back at a pH of 8. So even though this eluted in a pH of 12, as soon as we put cytochrome C back into a pH of 8, it will revert back to its positive charge, okay? So now we can go on and have a look even further. So we know that this is our BSA from row E, this was our cytochrome C that was in row G, and these were our standards. So I want you guys to draw a picture of this. You'll find a spot in the booklet that you would have downloaded. I want you to hand draw a picture of what this looks like. Make sure you put in your origin line for me. Make sure you label the positive and the negative ends. And then I want you to answer the questions that are in that booklet about why did they get drawn to certain ends. And that's it. So that's goodbye from me. Am I out of focus?
Yeah.
There I am.
There she is.
Okay. Thanks, guys.